what kind of function I've been talking about? What? What kind of function we have been talking about? Quadratic function. The reason it's called quadratic is because
It's on a quadrilateral.
yeah,
There are two answers.
the two answers. Okay.
You're not
No, it's not wrong.
There are four different.
What is that means quadratic?
Four.
No, it's not full. It's not full. The quadratics, it means squaring.
That's what I meant. Yes.
Squaring. That means you have an x term. You have a independent variable which have a squared power to it. Okay, so any function have this. Now doing this.
X versus more X.
Okay, so this is what means by quadratic function, because this term, because you could have something like this. You could have 2x squared plus x. It's still quadratic. So this can be 0. Okay? Now, you could have this. It's still quadratic function. This can be 0. The only thing we cannot be 0 is this. A cannot be 0. If A is 0, it ends up with something like this. Which is what? What function is that? Linear function. Okay, so when we're talking about quadratics, we're talking about this guy here. Because this x squared, that term, okay? That makes quadratic function. And quadratic function has properties. Is that it's going to be had, you'll have acts of what? Symmetry. So any quadratic function has something go like this. Acts symmetry. Okay. Or you could have something like go that. You still have the symmetry. And this point is what is this point called? Vertex point. Okay. So because you have this shape, then you can have, in this case, this is our a greater than 0, we have a maximum or minimum. There's minimum value, right? In this case, is a less than 0. Do we get maximum or minimum? We get maximum number here, okay?
Yeah.
Right?
Yeah.
Okay. So now, because from that we got function is called quadratic, not function, equation. Quadratic equation. Right? And quadratic equation, that means we have this, x-intercept. Now, it's either called the roots of the function or zeros of function.
Yes.
And for any quadratic function, there only have 3 situations in terms of zeros. The first one is that you can have two distinctive zeros. So that's different, 2 distinctive. 2 zeros. Why is on this side have this problem?
What is that?
Two arrow.
The right side. Oh, you do something.
That's one case.
You want to rewrite that?
Huh?
I mean, I could.
I don't know. Sometimes you do this weird thing. Okay, number 2. Number 2, we have what?
Well,
That's right. This side is actually not correct. Number 2. This is 2. How many zeros we have? Yes?
two things. One, the answer to your question is 1.
What is
Zero.
Which one?
You have 1 0.
First one, this is the 2 distant
Yeah.
zeros. Here, do you have 1 or 2 zeros?
1.
2.
1.
2 zeros.
1.
Well,
It just happens to be on the same point, but it's considered 2 zeros.
Okay.
So, 2
Oh, okay.
identical zeros. And that's also called double zeros. Double zeros. Okay, just remember. Yes? Yes, Hannah?
Okay, why is it, you know how like lines can be
Yeah.
diagonal? Why is it that parabolas are never diagonal?
The problem is always like this. Either here,
But
here.
why? I mean, it can be
That's
sideways.
just the
Just
why can it be like that?
that is the definition. When we talk about parabolas, it's always like this.
So, I mean, what is the parabola? Oh, yeah, it can be sideways too, right?
It can be sideways.
Okay, why can't it be on the diagonal?
Like what?
I mean, like, what would that be called?
You mean like?
Yeah.
Well, it can as a problem. It can, but it cannot be a function.
Because, well, I mean, sideways one can't either.
Otherwise, it cannot. What's that? Say.
The line test.
Well, what kind of line test? Vertical line test, right? So this is not quadratic.
Ah,
This is not a quadratic function.
what is it then?
It's just a graph. It's a problem here. Okay. So when we're talking about functions, quadratic functions, it's either like this or they go like this. Okay. The x of symmetry is always parallel to the y-axis.
Yes.
Because otherwise we will fail the vertical line test. Okay? So that's why we have this. Okay. Alright. So this is called double zeros. So actually it's 2 zeros that happen at one point. Okay? So this is different from here. The reason for that is here. Let's say x. Now, simplest case is this.
No, it doesn't.
X0 is 0. This actually is made of what? 2x here, right? Right? So the 0 has to be x0 to solve this problem. But there's 2x, so it's 2 zeros. This is different from simply this. It's just 1. Okay? Right? That's what we call double zeros. So, now, we're looking for something like this. Either here or here. Now, do we have zeros here?
Yes.
3.
Yes.
Yes?
Yes.
Okay. Do we have real zeros? No. So what do we have? Huh?
Complex.
Complex zeros.
Yeah.
That's 2. It has to be 2.
That was really easy.
Okay. Remember, we're still doing calculus, okay? And this is actually for us to, when we're doing calculus, we are dealing with properties. We are not really interested in the specific value, number anymore. We're not interested like what it is. We want to say what properties they have. Okay, so that's what we see here, right? That's we study this function. We know they have these certain properties. They always have two zeros, but could be two distinctive real zeros or one double zeros, which is real, or two complex zeros. Okay, so that's what we're looking at. We're looking at the properties of this function. Yes.
What is the 3 for? Is that the third graph?
What?
3. The 3 by no, I
Here?
yeah.
That's the third situation.
Situation. All right.
So we have three situations. Okay. Three, right? The first one is two distinctive real zeros. Second one is double zeros. Third one is two complex zeros. Okay? We good on this one? Everybody? Okay. So now, how do we know they are? How do we know they don't have real zeros?
Because they don't have
Graphing it is easy. Graphing it is easy, right? Once we graph it, we know that there's no real zeros. But how do we tell from this form? How do we tell, just based on A, B, and C, how do we tell that? And by the way, A, B, C, those are all real numbers. Okay? We are studying, in terms of functions, we are studying real functions. And if someday you want to do more in math, you're going to be running into functions called complex functions. Then all those A, B, and C will be complex numbers, not just real. But so far we're just studying real functions. Real functions can have complex zeros, but those coefficients, this is called coefficient, they're all real. Okay. Now, if we know something like if we know A and B and C, how do we know whether or not they have complex zeros? How do we know that? You guys learn that. Based on what? There is a formula for that. Based on what?
quadratic.
Based on what? How do we know we don't have real functions? Based on your quadratic formula, you should see that. Yeah, but what do we know?
It's because it's b squared minus 4ac has to be positive. And if it's negative, then it's in that.
Which is what?
Like at that part, whatever's in the radical.
Yeah. So, in order to have real zeros, b squared has to be greater than what?
4ac?
4ac, right? So this we got real zeros. Okay, and if b squared is greater than 4ac, we have what? What situation is this? We have 1, 2, 3. Which one? Which one? No, it's greater than that. B squared is greater than 4ac. We've got 2, right? Yes. That's 1. And b squared equals to 4ac. Double zeros. And b squared less than 4ac, which is what? Huh? Third, right? So basically, whatever inside the square root, if it's negative, that means we end up with complex zeros. Okay? So that's the thing we check. Yes.
The numbers is that related? Is that really the situation?
Yeah. Yeah. So situation 1, situation 2, situation 3.
What was the first situation?
First situation, we have 2 distinctive real zeros.
Okay.
Second, we have double zeros. Third, we have 2 complex zeros. Right? We are good on this one?
Wait, what was it?
Two distinctive real zeros. The definition is different. And which happens here, right? Graphic is easy. It's right happening here. Okay? Alright. We good?
Really good.
Okay, but now I'm going to show you why in this case. Now, based on this, based on the formula, we can tell, right? Why is that? But there is also a graphic way to tell what that means by that. Why this works, okay? So, this is based on our famous, the other form, the vertex form, okay, which is right as well. Y equals to A, x minus h squared plus what? K, right?
Oh, yeah.
Remember that?
Yes.
And remember how we got h and k from A, B, and C?
Didn't we have it 1 over 4?
No.
That's what I
Yeah, there used to be 1 over 4D, but now 1 over 4D basically just A.
Alright.
Yeah, 1 over 4D is A. So we used to do this, but they're the same.
Okay.
Okay. But good memory. Okay. Now, remember, if A is positive, when do we have complex zeros? This is greater than 0, therefore the graph has to be here, right? If in this case, we don't have, we have to have the complex zeros, right? We don't have real zeros. We good here? So now, which means what? This is our h. This is the k. So in this case, if a is greater than 0, and if k is greater than 0, we have 2. There's no real zeros. Okay. Huh?
I can't remember what A does to it.
Well, A depends on negative, positive. If it's positive, it's always go like this. If it's negative, it's go like this. That's what that
Does it move it up and down?
No, A doesn't. H does. K does.
What does,
K moves up and down. H moves left and right.
does it determine its slope?
Huh?
Does it determine the slope of it?
For this one?
A? Yeah.
A? It does affecting the slope.
Can it?
Okay.
Yeah, but that's what later on we'll find in calculus.
Oh, I see. So if A is positive,
It's always like this.
but that wouldn't mean that there are definitely, just because A is positive doesn't mean that there are definitely imaginary answers, right?
Well, it has to be this. If A is positive, then, and also, if K is positive, then there's no real zeros.
Right.
Because K is above this line, right?
Yeah. Okay.
Okay.
I'm on board.
Good enough?
Yeah.
Okay, but how do we figure out K? Remember what's our K? Remember what does K?
K is
K is?
y.
Equal to what?
4AC over
4AC minus
minus b squared over 4.
over what?
4A.
4A. Right? Okay? Remember, if this is a positive, that means our graph has to be above the x-axis, so we don't have the x-intercept point, which means we don't have real solutions, right? So if k is positive, what happened to this part?
It becomes positive.
4ac minus b squared has to be what? Over 4a?
Yeah.
Positive, right?
Yeah.
Right? Right?
Right.
We good? So are we good here?
Still good.
Okay, make sure you understand this, okay? This is very good. This is help you to go through the exercise, okay? In terms of algebra, okay? If you are good on this one, algebra will be no problem.
What are the consequences of not being positive? That's just the same thing that was in the square root of it, right? Well,
Yes, yeah.
Okay.
But now we're looking at the graph. So if k is positive and a is also positive, then we don't have real zeros, right? Because it's k above the x-axis, right?
I was saying this 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 term for?
Yeah, this is from the vertex formula, right? Because we know k is equal to that. So if k is positive, then this has to be positive, right?
Yeah, what are the consequences?
Well, here we'll see. If that's the case, and because a is positive, we multiply 4a on both sides, what we got?
Oh, yeah. I mean,
4ac minus b squared has to be greater than 0, right?
so what was
Right?
Right.
And therefore, therefore 4ac has to be greater than b squared, right? Right? And this is the same thing as b squared is less than 4ac. See, that's back to what we had before, right? Remember, we had that here already. But we're based on this. We're based on that. Right? So if b squared less than 4ac, we don't have real zeros, right? Situation 3, right?
Oh, yeah.
But this allows us to see graphically. Because if a is greater than 0, the k, and if k is also greater than 0, there's no intercept, right? And then that gives us this, right? We got this part. So, we got this part. Are we good here so far? Right? We good? We good so far? So, but there's another situation, is a less than 0, what happens? If a less than 0, we got something like that. If the graph is like this, when this happens,
Well, you calibrate it.
yeah, when this happens, what's our k?
Zero?
Less than 0, right?
K could also be.
K could be positive, but positive then we have x cross. If it's positive, we got this. So we have the real zeros. But in order not to have real zeros, k has to be less negative, right? Because so far. But remember what our k is. What k is what? K is equal to 4ac minus b squared over 4a, right? Right? And if k is less than 0, which means 4ac minus b squared over 4a less than 0. Right? We good? Questions? We good? We good? So now, you see what happens. Now we're going to multiply 4a on both sides. Because a is less than 0, what happens?
Turn it.
A is less than 0. Multiply a negative number.
Change this.
Right? Then what? We got the same answer, right? This has to be greater than b squared, which is same thing as b squared less than 4ac. Right? We got the same condition. So, no matter what, if b squared is less than 4ac, there is no x-intercept point. Therefore, no real zeros. And therefore, we'll have two complex numbers. Okay? Good on that? Yes? Okay? All right. So, another thing I want to talk about is when you're dealing with the complex numbers. And do you figure out what they're called?
No, I can't remember the thing. I looked it up, and I remember, and I was like, oh yeah, that's what they're called. And
Okay.
then I forgot to again.
You are too.
Okay. A, same A, B, same B. The only difference is this,
There's
plus
signs
minus,
between.
right? So that means, let's say, for example, 4 plus 3i, 4 minus 3i. This is the same. Okay. This is called, this is the name. Start with C. Conjugate.
Yeah, that's what it is.
Yeah. So each is conjugate. The only difference is plus negative, okay? And if you look at the zeros for our negative b squared, no, b plus minus b squared minus 4ac 2a. This quadratic formula, we got two complex zeros. But if you look here, 1 is what?
1.
1 is minus b over 2a plus I, right?
That's a plus or minus.
4ac minus b squared over 2a. This is 1, right?
Plus or minus?
No, this is 1.
So maybe this is what? Where do we have to get that?
From here, there's 2. This is a combined form. We separate them out. One complex zero is this.
Oh, okay.
Positive. Another complex zero is this.
You can do the other. It's going to do the minus.
Okay, right?
Where did
Notice I shifted this because this is positive, right? Here, this part is negative, but once I shift it, it's positive, right?
Dad, you need to go
But
back.
negative 1 is come out. Huh?
You need to go back.
That's okay. Take a look a little bit. Take a look a bit. Okay. How do we get from here to here?
No.
Oh, you separated them.
Huh?
Where did the
Like from the square root of negative 1.
Where?
Because I changed this. See the difference?
Right here, Abby, right here.
Yes.
Okay.
Wait.
Okay, give me 1 second.
Okay, yeah, I see it now. I see it now. Okay. Wait, you can't just wait till you.
She just did it.
Negative, positive,
yes,
same thing, right?
I'm good.
Okay, this is what we can write like this,
Earlier, you said.
right?
To take out an I.
Okay. What do we have?
Okay.
This.
I.
Alright. So that's where we come from, okay?
Yes.
We're good, right?
Wait,
Okay, yes.
why are we taking an I out? What did you find the I?
Deal with imaginary numbers.
Oh, I saw. Okay. Oh,
Deal with
okay, yeah.
imaginary numbers.
Okay. Right, good?
Wait, okay. Why are we taking the I out in the first place?
Well, because we want to write as a complex number.
pay it.
This is a complex number.
Why do we want to write it as a complex number?
Because it is a complex number.
What is a complex number?
You have I there.
Okay.
Have both real and imaginary.
That means why are we making it complex?
Because A is less than
Because it is a complex number.
Because we have decided that it is.
No, it is complex number because this part is less than 0, so square root of that
We
comes
have
out.
decided that it is less than 0.
What did you decide? We just said that if there is a complex number,
But it
That's
has
what
no
happens.
value. It has no value because the
it doesn't matter. Remember, we are looking at the property. We don't looking at the value anymore.
We have decided that it is
Yeah.
We are abstracts. Is abstraction.
Okay.
gave it value.
Right.
Gave it.
Right. Let's see this. B squared is less than 4ac. How's that?
2.
Okay. We good on this one? Go based on from there. Okay. B squared less than 4ac. So therefore, this one is negative. Square root of that gives us an imaginary number. So therefore, we have both complex part, real part, imaginary part. We got a complex number, right? But this is not there yet. The point here is trying to show that x1, x2 are what kind? Or what kind to each other?
Conjugate.
Hey, get back to your seat.
Here, right?
Yeah.
They have the same real part,
Crazy.
same imaginary part. The only difference is one is plus, one is minus. So there's two, x1 and x2 are conjugates.
What does that mean?
Okay, we get it?
What is conjugate?
We need like a gentleman.
Conjugate just means that
The different or the same?
Yeah. they have the same real, same imaginary. Only difference, one is plus, one minus. They always go in pairs.
Okay.
And later on you'll learn that for polynomial functions, if they have complex zeros, they all come with pair. They've never been single, always paired, okay? So they're always conjugates. All right, we good?
Yeah.
Okay, now we need to go a little bit more about what that.
Whoa, I just missed that. Where did that appear from? Hold on. Never mind.
Okay.
I'm sorry. I'm just gonna go. Oh wait.
Okay.
Sorry. What?
Now, they all come down to understand the conjugation is that you have to know how the complex number is represented graphically. Have you learned that, how to represent the complex number? So if we have 2 plus 3i, how do we graph that?
Where's Kobe? Carefully.
Anybody remember?
2 minus 3i.
No. What we're going to do is this.
Oh, how to graph it?
Okay, we're going to have this is our real axis. This is our imaginary.
Is this even a thing?
Okay,
Making all this up.
you guys remember that?
We never.
No, we definitely never.
Remember? I'm sure you guys did, just so you don't remember. Okay,
I'm pretty sure.
all right. Right?
No, we didn't do this.
Okay, so in order to store this, what we need to do is 2 here, right? 3 here.
That's it.
And this point
No.
is that.
What?
2, 3, that represents this.
That is not good enough.
Okay, that's point, right?
But it's not easy.
I thought it was
So-
going to be something really difficult.
So now we can graph it, complex numbers, okay? We just put real as axis, imaginary as another, okay? We good? We good so far? Okay, so where is, give me 1 minute, okay? Where is 2 minus 3i?
You go over 2 and down 3.
1, 2, 3, right? Right? We're going to here, right? Okay, so here is a conjugation. If you draw the line here
I wish I had
to this one,
Oh, it's like momentum.
I cannot draw that clearly.
You got it.
Okay,
Just like it.
this, there's a special property. This angle
90
goes to 90 degrees.
Listen, it's beautiful.
Okay, conjugation,
That's cool. That makes sense.
right?
No.
Good?
Yeah.
All right.
Oh my gosh, that's a beauty.
Yeah.
That's gonna be